Okay, here we go. This is Final Exam Review, Part 1. So in this question, we're given a reaction and we're given the heats of formation of the different reactants and products. And the key thing to remember here is that the heat of the reaction, the change in enthalpy, delta H, is given by taking the total heat of formation of the products minus the total heat of formation of all the reactants added together, and whatever the difference is between those two, positive or negative, is the overall change in enthalpy, or delta H. So if we add all the products together, we find that we have negative 877.1 plus negative 285.83 plus negative 393.51. Okay, that's all of the products, which is the calcium chloride, the water, and the carbon dioxide. And then we're going to take all of that, add it together, and we're going to subtract the sum of the reactants, which is negative 1206.9 plus 2 times, because there's 2 hydrochloric acids, heat of formation of hydrochloric acid is 176, or negative 176.16. Okay, so we add the products together, we add the reactants together, and then we subtract the total of the reactants from the products, and we end up with negative 15.22 kilojoules. So that is closest to this answer right here, number 4. Forgot to mention at the beginning, the order of the answers may be different on your sheet than the order of the answers on this review, but the actual answers should all be the same. All the data should be the same. The question should be the same. It's just that some of the answer choices may be in a different order. So check your answers, not necessarily the number that you selected. The chemical reaction 2H2O plus energy produces 2H2 and O2 is, well, it's not synthesis because we're breaking the water up. It's not ionic. It is not exothermic. It is endothermic. Anytime energy is on the left-hand side, that means it is endothermic. It needs energy to get going and to continue to go. It takes energy to break apart water molecules. So that's an endothermic reaction. So we have another reaction here. Carbon monoxide and oxygen produce carbon dioxide. We're told that the enthalpy change is negative 135 kilocalories. And the question is, how much heat would be released if 12 moles of CO reacted with excess oxygen to produce carbon dioxide? And so the key here is sort of a little bit of stoichiometry, a little bit of thermochemistry, but we can treat the 135 kilojoules, or kilocalories rather, as a product, because that's an additional product, 135.28 kilocalories over here. So if we are given 12 moles of CO2, how much energy would be produced? Well, given 12 moles, for the reaction to take place, it takes 2 moles of CO2 to yield that 2 moles of carbon monoxide to yield 2 moles of CO2 and 135 kilocalories, 0.28. So we do the 12 times 135.28 over 2, and we end up with 811.68 kilocalories, which is the first choice on this one, but might be a different choice on yours. If it takes 55 kilojoules of heat to change the temperature of a 200 kilogram hunk of metal from 28 degrees Celsius to 29.18, what is the metal? Well, we're given the specific heats of the metal, so we need to figure out which specific heat corresponds to the problem, and then we can identify the metal using that. So we've got the energy change, or the temperature change rather, which is 1.18 degrees Celsius, right? Because it goes from 28 to 29.18. We know that it is 200 kilograms, which would be 200 times 1,000 grams. Okay, what we're looking for here, the specific heat is the amount of energy divided by the mass times the change in temperature. Sorry, that's the formula that we're going to plug all this into. So the specific heat is equal to the amount of work, 55 kilojoules, or 55,000 joules, divided by the mass, which is 200 kilograms, or 200,000 grams, times the temperature change, which is the 1.18 degrees Celsius. And when you do all that math out, you end up with a number very close to 0.233 joules per gram per degree Celsius. And that corresponds most closely to this one, which would identify the metal as silver. Okay, so we need the standard reaction enthalpy for this one. This problem got cut off, so I'm just going to recreate the information that's missing, and then I'll give you the answer at the end when we show you how to do it. So the reaction that's missing that we were given is 2NO2 plus, produces N2 plus 2O2 with a delta H of negative 66.4 kilojoules. Okay, so this relies on what's called Hess's law, which says that if we can take a series of reactions and sort of use them to build the reaction that we want by canceling things that appear on both sides, then the energy or enthalpy change of the reaction that we have built will be equal to the sum of all the reactions that we used to build it. So in order for us to get the reactants and the products the way we want them, we are going to need to reverse both of these reactions that we're given. So we're going to end up with 2NO produces N2 plus O2, and because we're reversing this first reaction, we need to reverse the change in enthalpy, the sign. So that means it's going to be negative 180.5 kilojoules. And then if we reverse, sorry, the problem's going to be under this line. If we reverse the second reaction, we get 2O2 plus N2 produces 2NO2. And again, we have to reverse the sign. So this would be positive 66.4 kilojoules. Now, when we take those two things together, we cancel out the things that are on both sides. We can cancel out the N2 on both sides. We can cancel one of the O2s. And so what we end up with, when we add all that together, is 2NO plus one O2 that was left produces 2NO2, and when we add the enthalpy changes together, we get a delta H of negative 114.1 kilojoules. So that is the answer. Whichever choice that is on your sheet, that's the answer, negative 114.1. Okay, another Hess's law situation. We need to take a look at these three reactions. How can we combine them in order to get the reaction that we want? So we're going to take the first reaction and the third reaction are actually good as they are. We're going to have to flip the middle reaction around. So what we end up with is N2H4 plus O2 produces N2 plus 2H 2H2O. And we flip the second one around, 2H2O produces 2H2 plus O2. And then the third one is the N2 plus 3H2 produces 2NH3. And the energy changes we have, so let's see, we can show where all these are going to cancel out. So the O2, that's on both sides, that gets canceled. The N2 appears on both sides, so that's going to get canceled. The 2H2O are going to get canceled. And then 2 of the H2s are going to get canceled, leaving, when you add that all up, you get N2H4 plus H2 yields 2NH3. Okay, so that's the reaction we wanted. So then to find the energy, we take the energy of the 3 reactions up here. The only difference is this second reaction, we flipped it around, so we make that a plus 484 instead of a minus. Total all that up, and we get negative 151.2 kilojoules. Okay, which is closest to the 151 answer there. Which of the following is true about electromagnetic radiation? A length of 600 nanometers has a lower frequency than a wavelength of 400 nanometers. Wavelength and frequency are inversely proportional. So bigger wavelength means lower frequency, shorter wavelength means higher frequency, which makes sense if you think about wave that they all travel at the same speed. So obviously a wave that is shorter is going to get past your imaginary point in space more quickly than one that is longer. So they're inversely proportional. Frequency goes down as wavelength goes up. When an atom gets excited, or is excited in this case, in its initial state, we're going to call the excited state, and it gives off a photon. The photon equals energy. So that's how electrons move up and down. They absorb energy, they release energy in the form of photons. So photons equals energy, which means if you're giving away energy, emitting a photon is the same as giving away energy, then you cannot have the same amount of energy that you started with because you just lost some. So that one would be false. How many orbitals, how many electrons can a single f orbital occupy a single f orbital? So a little bit tricky wording here. Orbital is actually the little regions within the sublevel, which is the f sublevel. So any orbital, whether it's s, p, d, or f, can only hold 2 electrons. Now, the f sublevel has 7 orbitals, so the f sublevel could hold 14 electrons, but this specifically says an orbital, and any orbital can only hold 2 electrons. What is the maximum number of electrons that the second energy level of any atom can hold? Well, the second energy level has an s sublevel and a p sublevel. All s sublevels can hold 2 electrons. All p sublevels can hold 6 electrons. 2 plus 6 is 8. So the second energy level of any atom can hold up to 8 electrons. We have 1s2, 2s2, 2p2. What is true about this atom? The atomic number is 6. Well, that's true because it's got 6 electrons, and we're assuming it's neutral because it says so. So 6 electrons means it's got to have 6 protons and be atomic number 6. The electrons are in 4 different orbitals. Well, let's see. If we do the orbital diagram, 1s, 2s, 2p, and we have 1s2, 2s2 electrons, 2p2. Well, those 2 electrons in the p sublevel can occupy separate orbitals because they can. They're on the same level. So they do have 4 different orbitals. 6 protons, yes, that means atomic number 6. And 2 unpaired electrons, which are in that p sublevel. So the correct answer here is that they're all true. What is the ground state electron configuration of a chromium atom? Chromium is atomic number 24. so it needs 24 electrons. These are all written in the noble gas notation with argon as the noble gas. Argon is element number 18, which means we need another 6 electrons to come after that. Now, this is not necessarily the way that we would teach it, or the way that we have taught it is effectively this answer right here. And we would actually write it as argon 4s2 3d4. So this would be the answer that you'd be looking at on the final, but this is how I would expect you to write it if I was asking you the question on the final. What is the electron configuration of the Mg ion, the magnesium ion with a charge of +2? Well, magnesium is element number 12, which means normally it has 12 electrons. But the fact that it's a +2 ion means it has lost 2 electrons, so now it only has 10 electrons, which is the same as the neon noble gas. So the first thing we need to do is look for 10 electrons total, and then we need to look at the ones that look like neon. Neon has a configuration of 1s2, 2s2, and 2p6 because it's got its whole second energy level filled. The only choice that matches that would be number 4. Arrange these in order of increasing electronegativity. Well, the first thing you need to remember is that the general trend in electronegativity, first of all, fluorine is the king of electronegativity. The trend is moving up from bottom left to top right, not counting the noble gases. Okay, they don't have electronegativity, so that makes fluorine the top right-hand corner, which makes it the most electronegative. Since it's increasing, that means we want fluorine at the end, so that eliminates those two choices. And then it's a question of which of these others are in the correct order. Well, the silicon, phosphorus, and sulfur are all one row below fluorine. And then the carbon, nitrogen, and oxygen are all in the same row. So which, you know that they get smaller as you go away from fluorine. They're all going away from fluorine. Which is the most, or which is farther from fluorine? Well, this row is closer to fluorine because the trend goes up in electronegativity as you move up in the rows. So the correct answer is the one that has carbon, nitrogen, and oxygen closest to fluorine. Which of these elements has a second ionization energy that is lower than its first ionization energy? Well, no element has a lower second ionization energy than first. Ionization energy always increases from first to second, second to third, and so on. The gap between first and second, or second and third, may vary, but it never goes down. Because once you start taking electrons away, any remaining electrons are pulled in more tightly, which makes it harder to get the next one, and then the next one, and so on. So no element has a second ionization energy lower than its first. When do atoms form a chemical bond? Well, everything in chemistry is driven by the desire for more stability, or another way of looking at that would be lower energy states. Everything is trying to get to the state that requires the least amount of energy to maintain. So more stability equals less energy, right? Something that's more stable requires less energy. So atoms bond in order to become more stable. So what's the electron geometry of the nitrogen atom in nitric oxide? So this is an unusual case where you have two nitrogens, but oxygen is not the central atom. So we're going to draw this out. We've got nitrogen, oxygen, and then nitrogen on the other side. It's unusual. This would actually work out whether you put oxygen in the middle or not, or nitrogen in the middle, but the question's asking about nitrogen because technically nitrogen is the central atom here. So when we do the NaSl, 3 atoms need a total of 24 electrons to fill their valence, 8 apiece. Available, we have 5 from each of the nitrogens and 6 from the oxygen for 16, which means we have to share the difference, which is 8, and we're going to have 8 left over. In order to share 8 electrons, we need to make 4 bonds, or 2 double bonds. And then the 8 remaining electrons are going to get distributed around the terminal atoms on the outside. So when we look at the nitrogen in the center, it has 2 regions of electron density. The farthest apart those 2 electron regions can get is 180 degrees apart, which makes this a linear molecule. Which of these pairs of atoms has the largest dipole, or would be the most polar, is another way of saying that? Well, we can certainly eliminate these 2 choices because they're the same atom, so they don't have any dipole moment. So now the question is, which of the remaining 3 it would be the greatest dipole? And the greatest dipole moments are generated by the greatest difference in electronegativity. So the 2 atoms that are the farthest apart are carbon and fluorine. Carbon and nitrogen are right next to each other. Carbon and oxygen are 2 apart, but carbon and fluorine, they're in the same row and they're 3 elements apart, so they would have the greatest dipole moment. And that's it for part 1. Moving on to part 2.